Welcome to a quick video tutorial on how to factor the difference of perfect squares. So this is a very special type of um, polynomial that we'll be factoring. The word difference means there's going to be a subtraction sign there. And perfect squares means the two things that are being subtracted are both perfect squares. And so you will notice in the examples we'll be doing in this video, both of these are perfect squares and there's a minus sign between them. Same thing here, same thing here. So whenever you have a binomial in which the first and the second are both perfect squares, they're going to factor into the product of two binomials, a plus b times a minus b. So this expression here and this product of two binomials are equivalent. And when you're asked to factor something, we're looking to write it as the product of two binomials. So here I have my difference of two perfect squares. I'm asked to factor it. So I want to take the square root of the first term. I want to take the square root of the second term. And we will have a plus sign and a minus sign in between them. So this is actually a really nice type of expression to factor, and we want you to recognize these because they're really important. You'll be using these again as your algebra and your math experience gets deeper. And just to prove that my answer is right, I'm going to write 4x plus 5 along this row and 4x minus 5 along this column. And now I want to use the box method of multiplying polynomials to prove that the product of these two binomials is equal to the given. All right, 4x times 4x, 16x squared. 5 times 4x is 20x. 5 times negative 5 is negative 25. 4x times negative 5 is negative 20x. And what you're going to notice is along the diagonal, these are additive inverses. They will add together to equal 0. So what we end up with is 16x squared minus 25, which is what we were given. So now with confidence, I can state that my answer is correct. So let's do this one over here, 121 a squared minus 100 b squared. Once again, both of these terms are perfect squares. So what I want to do is figure out what's the square root of the first term. Well, that would be 11a. And I write that in both first spots. And then what is the square root of the second term? That would be 10b and 10b. I have to put a plus sign and a minus sign in no particular order. This time I'm writing it in the reverse order. And so my claim is that this is correct. I could, of course, if I wanted to prove my answer, of course, I could apply this out using the box to prove that my factor is mathematically equivalent to the given expression. And now it's going to be your turn. And what I would love for you to do is to factor this binomial, recognizing that it follows the structure of the difference of perfect squares. Please put the video on pause, write out your factored form, and then please double check by multiplying your two factors using the box to make sure that it's equivalent. Okay, so here's what I hope you got as your answer. Square root of 64 being 8. Square root of 9y squared being 3y and 3y. We have to have a plus and we have to have a minus. Then I had asked you to please multiply this out to make sure that your answer was correct. So hopefully you wrote 8 plus 3y and then 8 minus 3y. When you multiplied this out, you got 64. You got negative 9y squared. And these two are going to cancel out. So I'll put them in a different color. I'll put them in yellow. 8 times 3y giving you 24y. 3y Oh, okay. I got confused. Negative 3y times 8 giving you negative 24y. Now I can see that these definitely cancel out, leaving me with what I had started with originally, proving that my answer, my factored form here, is correct.